this stuff is not really trained into the language model. You can't just have a model that understands what's going on into your private financial account, right? And so in all of those situations where you don't just want to talk to the model, but you want to talk to the model about something, this something has to be provided to the model basically at the time of the conversation and not really trained into it.
Okay, so on the Metaverse show today, I'm really happy to welcome back an old friend of Outliers, Daniel Svonava, who is the CEO and founder of Superlinked. Superlinked is described as a startup that turns data into vectors. What the hell are vectors? We're going to find out soon. Daniel and the team went through, we were just discussing up there, trying to figure out when, one of the Basecamp programs, I think it's Basecamp number 2, just before COVID kicked off. It's actually when we were doing them physically in London and we had to kind of send everybody home quite some time ago now, decades in the context of the technology world. And we were due a catch up. I saw him doing some very interesting things on LinkedIn, saw him talking about vectors and thought, what the hell's going on over at Superlinked? Let's have a catch up. And of course, why not record that? Actually, the program that he went through was with some of our other portfolio companies like Biconomy and Crucible. So a very strong vintage actually for very early set of cohorts in our accelerator life cycle. Daniel, you've got a really strong background. I remember that was one of the things that really impressed us when we kind of accepted you into the accelerator. Very strong background in machine learning, I think data science as well. Coming from Google, several patents that you were involved in during your time at Google. And of course, Superlinked has now evolved, not technically a Web3 startup. I think you kind of refer to it as Web3 adjacent. Obviously, at Outlier, we've been talking about the convergence of AI and Web3 for some time. But it's going to be interesting to kind of hear your journey over the last, 3 years or so, how Superlinked evolved, and I guess the big problem that you're working on now. But maybe before we do that, let's just have the audience learn a little bit more about you and your background, and then we can get into the evolution of Superlinked.
Thanks a lot, Jamie, for having me. Really great to catch up after all this time. As you said, 3 years in tech startup land, it's a long time. So yeah, just maybe starting out just quickly on my background, I'll do reverse chronological. You mentioned my time at Google. Specifically, I have been a tech lead at YouTube, building machine learning infrastructure there in the ads part of the platform. So, that's kind of the ruthless world of relevance and latency, right? Everything has to work quite fast. The system has to learn from every user interaction, and it has to show people what they want to see or what they might click on. Otherwise, the platform doesn't make money and the whole thing doesn't work, right? So I have spent about 6.5 years building systems there. Before that, I had my first startup, lots of learnings there in computational photography. So 2 engineers starting a company and then struggling on the negotiation of distribution contracts. So that was a super nice learning there. And then, before that, I'm originally from Slovakia, typical Eastern European technical background, coding competitions since high school. I interned before that at Google and IBM Research, publishing some original papers, and I got a patent as a Google intern. That was my first one with the company. For the last 13 years, I have been living in Switzerland. I'm just now about to move actually to the US.
So at the top end, I described Superlinked as turning data into vectors. So maybe we can kind of unpack that a little bit, understand the technology stack. But before we do, let's get into the kind of, I guess, the problem statement. What's the big problem that you're solving?
There is a few different angles here, but one of the ways I like to start is that nowadays companies and ecosystems generate a bunch of data of all kinds of different shapes and forms. Sadly, there is still this barrier in unlocking the value from it, right? So building dashboards and just kind of trying to understand what the data is cool. From my point of view, it needs to sort of plug back into the product somehow, right? It needs to make the end user experience better. It needs to, move a needle somewhere. And that unlock of turning data into something useful for the end user or for the product right now is basically blocked by the availability of talent. There is still so few, machine learning engineers, data scientists. They sort of block a lot of the work and they're overworked. And then there is tens and tens of times more of software engineers who don't really have the right tools to kind of build state-of-the-art systems that need to be trained on data and need to be deployed in production. So basically, we have sort of a talent problem in the machine learning world, basically, and in its broader acceptance and deployment into the market. I think this new crop of technologies that we now see, with the pre-trained models and with all the startups in this kind of current wave of machine learning, sort of new technology, I think a lot of them are trying to ease this bottleneck, right? Create tools that a broader range of people can use to apply to different types of problems. And, then we kind of go to what specific problem we work on. And you mentioned the tagline, which, is not necessarily very self-explanatory, of turning data into vectors. So maybe I'll just do a little bit on that, and then we can sort of see where we want to go in the conversation. So vectors, that could mean a few things. It could be when you convert your logo from a PNG to a vector file so that you can zoom in infinitely. I don't mean those types of vectors. Basically, when I say vector or vector embedding, I mean just imagine a point in a space. So it's basically a set of coordinates that you use to represent some sort of data on the input. So you have some sort of model. Imagine basically a box. On one side, you feed in data. It can be text, it can be image, it can be structured information. It could be like a time series, like a price ticker. And then you have a model that basically projects it into some sort of space with lots and lots of dimensions. And then it's a point. And then you have, the different time series being projected to different points in that space with the idea that the points that are near each other are related somehow, right? They kind of look similar, they behave similarly. There is something about their characteristics that the model sort of then places them closer or further apart in that space. Those points are the vectors. The models in the middle, we call vector embedding models. For example, one very famous such model family is language models nowadays, out there. The why would you do this? Like the why, right? Okay, why do you want to turn data into vectors? Is because by observing sort of what is then projected near each other and further apart, this allows you to understand what is related. So, for example, if you do this for your users and, let's say, products, you are an e-commerce company, the things that are projected near each other would be the users that might be interested in the product or the products that are sold together. And so then you can build a recommender system on top of that. Or you can feed these vectors as an input to another model, because they kind of compress the information of what the input is about, right? So if you have a price ticker that goes back 10 years, it's a lot of data, right? It's variable length data. You can project it to 300 coordinate point and then feed that to another model that needs to understand, okay, what sort of time series, what sort of tickers you have on the input. But now it's kind of compressed and it's made, basically you can say that these vectors are the native language of machine learning models. This is kind of the standard representation that is really good for training those models further and so on.
Is it that we can effectively create new data sets, which are kind of, I guess, predictive based upon historical data sets? So if we kind of run out of old data, which people argue is kind of, I guess, happening, creating limitations in how far large language models can progress. We need to then create, would you call this synthetic data in a way?
In a way, it's a representation of what you feed in. It's just kind of like a different way to organize whatever data you throw at it. So, for example, there is, one of the kind of marketing stance that one of these large companies that build the language models did. They took all of Wikipedia, let's say 100 million Wikipedia articles, and they vectorized this data set, right? So for each article, they found the vector, which, okay, you can visualize it to start understanding, how are these things related, not just by articles linking to each other, but by them talking about similar stuff, and mentioning similar concepts. So you can kind of like map out Wikipedia in this way. But then, as I said, it's also really useful if you want to train a model on top of Wikipedia articles. Now you don't have to feed the actual articles in. You can just feed the vectors that represent what those articles are about. You can build a recommender or search system on top of this. And now the search is not based on keywords, but it's based on meaning. There is still Wikipedia, and that's kind of the human readable form of that information. But for machines to start understanding what's actually in there, there is this kind of first step you do with the conversion to basically the ML model readable format, which is these vectors. And then you kind of go from there.
If we kind of look at the more famous LLMs that people are kind of using on a daily basis, ChatGPT and OpenAI, some of the communications that they've been putting out around potentially plateauing to a degree. I've even seen things where users are reporting a regression in the kind of quality of output. Can you maybe explain how vectorization could be applied here? Is it being applied there already? How might what Superlinked's doing, kind of help in that context?
Kind of stripping of some performance away from these models that are being deployed to general public partially has to do with safety. One of the main sort of concerns with these open-ended user interactions, right? If you compare it to previously, Google search, let's say, right? You type something in and then I give you links to different places on the internet. I shouldn't send you to bad places, let's say, but I'm sort of liable in a limited way. But if the website itself starts to answer and, there is a dialogue, it can go in all kinds of weird ways, right? And so one of the main concerns of especially the biggest companies that have something to lose already is to limit the set of things that can happen so that they also kind of limit all the stuff that can go wrong. There is a technique called fine-tuning where you basically have a technique where you take preferred answers for certain inputs, right? And you are trying to, you literally add to the model a certain additional part, which you then train to kind of discriminate to the types of outputs you want. And you try to remove some parts of the possible space of outcomes so that stuff is more under control. And often this can also lead to just less power from sort of perceived by the users, right? Because you are kind of constraining the model. So this is one of the things that's going on. But then in terms of, how is this, let's say you are, interacting with a chatbot, how are vectors related to that? Basically, the main idea here is there has been this sort of pattern crystallizing of how people build applications with language models. Because the thing is that if let's say you have some sort of financial application on your phone, right? And you want to talk to it, right? You want to ask something about your financial planning or something about your history. You want to understand what you are spending on, right? You want to have some sort of conversation about your own data, right? Or about the financial data out there, how it relates to your stuff. There are some financial reports and then there is your data. The thing is that this stuff is not really trained into the language model. You can't just have a model that understands what's going on into your private financial account, right? And so in all of those situations where you don't just want to talk to the model, but you want to talk to the model about something, this something has to be provided to the model basically at the time of the conversation and not really trained into it. And this is where this kind of retrieval of relevant information that is then shown to the model, and then the model kind of sees your question, let's say your financial history, and then can formulate the answer. This pattern of sort of combining the retrieval with the operation with the model, the keyword there is retrieval augmented generation. Those types of workloads, you are kind of you are retrieving bits and pieces of information from proprietary sources, public sources, that then is exposed to the model, and then the model produces an answer. And the way you do the retrieval, the finding of the relevant stuff that's relevant for the question the user just posted, this is based on vectors, because basically you take the question, you turn it into a vector, and then you have already prepared in your vector database or in your database that sort of holds all this potential information that you might want to surface, you have also vectorized all the stuff there, right? So you have sort of turned all your data into vectors, you have turned the question into the same vector in the same space. And then when it comes time to answer the question, you basically do a nearest neighbor search, right? You take the vector representing the question, you find the closest vectorized data points from your, from those different sources. You take the top 10 most relevant bits of information, and then you show it to the language model, which basically synthesizes the answer. That's how we build sort of systems that combine language models with proprietary data.
And so that kind of vectorization allows that to happen quickly with as little kind of compute intensity as possible, right? So quickly, efficiently, affordable, right?
You don't want to be sort of like going through, it's actually not feasible. Imagine you are, I don't know, some large financial institution or any kind of big enterprise. You have lots of data. The user asks a question, and then within a second, you want to pull out from all your different systems bits and pieces of information that might be relevant for that question, not just mentioning the same keyword, but actually sort of semantically relevant, right? And so you want to already have that all sort of prepared, right? Indexed in this vector space so that when the question comes in, you quickly pull out whatever is relevant and then surface it to the model and off you go. 101 stuff. This is the basics. The tricky part starts when, you build some sort of system like this, and then you realize, the results are still not super relevant or not very high quality. And then next step of the journey starts, which is feedback loops. Because any sort of machine learning system that you get to production in front of millions of users basically is all about constructing the feedback loops, right? Let's say I'm giving users these answers to the questions they asked. Are they sort of like liking the certain questions? Are they approving of them? Are they taking the action that the answer sort of recommends them to do or not? There is always this sort of like source of feedback that you then want to feed back into the process, right? So that then the way you organize the data adjusts based on that feedback so that the next time when you show an answer to a similar type of question, you'll do better. Right. And so then that's kind of that's when it gets like all very, very complicated. And that's when you need those machine learning engineers, of which there are very few. Right. And this is where we kind of hit the wall often in big enterprises. This is where you need this kind of new generation of machine learning products to help you do all of this, basically.
Would it be fair to say most large organizations have been deploying some form of vectorization, even in kind of a rudimentary form? Would you say it's the majority or it's the minority? I know it will depend on industry, but
I'm not sure if I'm allowed to say this, but it's like sex in high school. Everybody talks about it, but very few people are doing it. The discourse nowadays, the narrative is full of companies wanting to do more machine learning, more AI. ChatGPT hyped everybody up, right? So there is this mandate coming top down in companies. Hey, we need a strategy for this. We need to make it work. You have a bunch of cool demos flying around on Twitter, right? You kind of see stuff that works reasonably well. It's kind of impressive if the inputs are just right. And then the process starts, how do we launch this for our users? How do we launch this in the context of our regulations and our data? And that's where you need much more control. And we are super early in the process of actually getting these systems to production, even figuring out how to monetize these. Sometimes the technology is applied to existing problems where it's easy to see, let's say recommendation systems, e-commerce companies being able to sell more stuff, or fintechs being able to handle more support tickets faster. This is clear how this helps. But then there is a whole broad range of use cases with especially generative AI, where it's not so clear. Maybe the old companies have to adjust the business model. We'll kind of see what happens there. But yeah, we are very early.
A lot of the news came around OpenAI and ChatGPT. Initially, there was primarily a kind of share price discount to a lot of the big tech companies that market felt didn't have a comparable product or offering. And so they all started rushing out things. My understanding was much of it had been in develop for some time, but was like very basic. But everyone panicked and started releasing all their LLM products just to seem relevant, primarily for stock, the price of stock. And if that's the case for big tech, I can only imagine once you start going into the long tail of enterprise organizations that wouldn't necessarily even describe themselves as a machine learning company, even thinner, right, in terms of competency, capability, learning and stuff. So let's assume an organization has gone on this journey. They've kind of done that basic vectorization, I guess is what you'd call it, right, of data and data sets. And then they've hit this wall of being able to optimize it to kind of really tap into the kind of feedback loop. How does Superlinked then help them up their game?
Yeah, basically we have a product for this, right? So think of Superlinked as a computational framework that sits between your data and then the place where you want to put these vectors, right? And the problem is to connect those two places. I think the sort of like enterprise data landscape is reasonably clear. There has been this movement called the modern data stack that, over the last 5+ years, more or less achieved the process of centralizing enterprise data, cleaning it up, pulling it from all the different tools enterprises typically use, and delivering them to a couple sort of core data warehouses and databases. And there is this kind of first necessary step. Like if a big company didn't do this, then okay, start there, right? Get your data story in order. Then the next step is, okay, so the raw data is there. Now it's time to make it kind of ML model readable, right? And so for that, what happens today is basically you hire an ML team and they build custom models, custom systems, use pre-trained models where, available. You also have to deal with sort of like, are you processing all this data once a week, or do you have a use case maybe like in fraud where you want to very quickly, there is the next transaction and you want to really update your understanding of the account quickly, right? So there is that kind of batch versus data streaming kind of question. And you build systems there. And then basically the destination is either a vector database, and we should sort of spend a little bit of time on those. Or you are creating these data sets like the Wikipedia vectors, right? Where basically you just have like a big pile of vectorized data, and then you are using that to train other models, and you kind of go from there. But I think it's worth to kind of pause a little bit on the vector database front, because that has been one of the stories of this machine learning hype cycle, basically. There is a website that goes ann-benchmarks.com, where you can go. And so ANN just stands for approximate nearest neighbor, a type of algorithm that helps you very quickly find vectors that are near each other, right? You start with one, and then you very quickly want to find the other ones that are near it, right? To kind of build all of that stuff we discussed. And if you do it naively, then you have to like look through all the vectors, and they are big, they're 1,000-dimension big. So it's very inefficient. So you need algorithms that kind of give you approximate but still pretty good results pretty quickly. There is 15 plus databases that have raised, I think in aggregate in the last 2 years, $250 million or thereabouts. Lots of products in the space, lots of super cool solutions. Also, the incumbents of the database world are coming up with ways to sort of deal with this type of data, right? So MongoDB and other big players, Postgres has a PG vector and different plugins to organize this type of data. So there is a big effort in being able to manage vectors, right? Or search them, manage them. But then there is kind of the next question you have. Okay, so we have a place to put these vectors in, but how do we make the vectors, right? And that's the messy middle part where you need a lot of specialized talent. You need to build a lot of messy systems. It's this intersection between the traditional machine learning world and this new world based on pre-trained models, right? You need to reconcile those two. And that's the messy middle where we are basically providing a solution to bridge that.
Okay, very cool. And do you have, like from a market perspective, can you size that market opportunity?
An interesting exercise for folks who are kind of really into this, I recommend basically interviewing, practitioners who have bought a vector database from a vendor, or they're running kind of their own open source based vector database, and ask them what they spend more on, the vector database itself or the pipelines that feed it. From our research and from research of others that we have collaborated with, it seems that there is about sort of like 2-to-1 type ratio. So you spend about twice as much on making the vectors in the first place than keeping them around, basically. There should be a lot of opportunity in getting this right. Another way to kind of come at the question is to look at across all the machine learning workloads, right? Machine learning is used in all kinds of different problems nowadays, right? And you can basically go and slice that pie into what sort of thing you are computing, right? What's the shape of that problem? And there aren't that many types of these problems. Representation learning, which is just this whole problem of how do I represent my data in more efficient, more kind of relevance-driving way. The estimates differ, but it's probably somewhere between like 25 to 50% of all the electricity spent on CPUs in data centers are spent on finding representations for data, basically. Because this is the major sort of cost of building recommender systems that drive, all the kind of big platforms out there, right? Enormous component of all the fraud infrastructure, all the like behavioral fingerprints, all the kind of risk work. Already in 2020, about 10% of google.com searches were vector powered, by the way. And, that's a lot. There is a lot of demand in that sense, but it's all kind of bottlenecking and locked up in teams and contexts where you have the manpower and time and sort of risk tolerance to build bunch of custom solutions, basically.
Very cool. And yeah, I mean, of course, some organizations do and most don't, right? As you go into that kind of long tail, because of how competitive the marketplace is, as you say, for talent, how scarce it is, that the supply of human capital can't keep up with the demand effectively. As we said earlier, there's a very real pressure on every CEO, CTO of every major company to show how they're relevant in the age of LLMs as well.
Yep.
Look, Daniel, it's been really great catching up with you. Congratulations on surviving for this period of time, 3 years now, and evolving the product and the stack, and ultimately finding that big, juicy and highly valuable problem. It's been great catching up with you, and thanks for coming on the show.
Yeah, thanks a lot for having me. As a kind of part of the parting words, I want to highlight one launch that we have, that by the time this airs is probably out. So, as you have sort of observed during this conversation, the topic is still pretty obscure, right? Like there is just a bunch of stuff that we could, go into million rabbit holes, and the whole space is progressing super fast. And so our first kind of public launch actually is educational resource. So we call it Vector Hub. By the time this airs, it should be already out there on hub.superlinked.com. Maybe we can put the link in the show notes as well. For anybody who sort of was listening to this and is sort of mildly confused, but it sounds like it's an interesting area to explore, we have you covered. We have, I think we're launching with 15,000 words, bunch of different articles about use cases, sort of foundational articles about the space, right? As we kind of described it, from the data to the compute and the kind of vector management problems. So yeah, there is a resource for you, and we would love feedback from everybody. And also it's contributor driven for the most part. So yeah, real community exercise to just kind of map this stuff out and help people out.
Yeah, I think that makes a lot of sense, because clearly it's one of those things where it's perhaps a problem many people haven't fully realized they have yet, right? If they're beginning on that journey, you can kind of fairly easily predict is an inevitable one. So that kind of educational resource sounds like a great place to start to understand the problem effectively. Brilliant stuff, Daniel. Thanks for coming on.
Thanks a lot. Have a good one, Jamie.